Your favorite intermediate algebra class. We're going to write some equations of lines today, some linear equations, and then some direct variation equations. So let's talk about slope-intercept form. We've got these different forms again, y equals mx plus b. We've talked about that. M is your slope, b is your y-intercept. We got this point-slope form, y minus y1 equals mx minus x1. Okay, and both of those are useful for different reasons. The slope-intercept, of course, is useful if you have an m and a b, you have a slope and a y-intercept. Point-slope form is very nice if you have a point and a slope, as you can imagine by the name. And finally, if you have 2 points, you're going to use the slope formula and then use point-slope form. Okay, so let's go ahead and run some examples using that. So write an equation given m and b. Well, if we're given the slope and the y-intercept, we're going to use slope-intercept form. Okay, so let's say we just have this graph here. First of all, let's denote number one. What is our y-intercept here? Where does it cross the y-axis? You say, oh, right there at 0, 2, right? Oops, I wrote that wrong. 0, 2. So our y-intercept is 2. That's where it crosses the y-axis, right? Number two, what's our slope? Well, let's go ahead and count that. We know that slope is rise over run, so we can do this one of two ways. We can either say it goes from 0, 2 to 4, -1, and name that x1, y1, x2, y2, and then plug it into the y2 minus y1 over x2 minus x1. Or we can just count it off. Rise over run. So I got to go down 1, 2, 3, down 3. So I'm going down. Rise is my vertical change. I'm going down, right? Decreasing. And then how much do I run? 1, 2, 3, 4. Positive 4. So it looks like I have a slope of -3/4. Okay? Or again, you could have done y2 minus y1 over x2 minus x1. Well, now we say I have a slope, I have a y-intercept, y equals mx plus b, y equals -3/4 x plus our y-intercept, which is 2. There's our equation for that line shown. All right, let's write an equation given a slope and a point. So this time we have a slope of 2 and a point, so it goes through 1, 2. If we want to make this visual, it goes through 1, 2. And then it has a slope of 2. So if the slope is 2, we're going to go up 2, right 1, right? So up 2, right 1. I'm like, okay, what's the equation of that line? Have a point and a slope. So I'm going to use, this is what I have, I'm going to use a point slope formula where I have to plug in x1, y1, and m. So let's plug that in. Y minus y1 is 2x minus the x1. And then we're going to go ahead and solve that down for y. Put in slope-intercept form after this. Okay, solve that for y. That ends up being plus 0. So there it is. Y equals 2x. All right. So let's apply this to writing equations of parallel and perpendicular lines. Okay, so let's write this equation. A line that passes through 2, 0. So I got to pass through this point, 2, 0, but I'm parallel to this line, y equals 2x minus 1. Well, 2x minus 1, that minus 1 is your y-intercept, and it looks like we have a slope of 2, up 2, right 1. Okay, so I'm parallel to this, parallel to that, right? So this other one, in fact, let me do it for this 2, 0. So that's what I'm looking for, right? That green line equation, okay? Well, if two lines are parallel, they don't cross, they must have, as you know, the same slope, right? So to write this equation, I know, you know what, let me do this in green because I'm doing it for the green one. I know I gotta go through 2, 0, and since it's parallel to y equals 2x minus 1, I'm going to steal that slope. My slope is 2 as well for this line. Okay, so now I have that it goes through 2, 0, and I have a slope. So I have a point and a slope, I'm going to use point slope formula. And I plug it in. Here's my x1, y1. Y minus 0, 2, x minus 2. Solve that. There it is. That's the equation of that green line. Y equals 2x minus 4. Now, what if they would have said this same thing? I go through 2, 0, but instead I am perpendicular to that red line. I'm perpendicular, so I make a right angle. But I have to go through 2, 0 again, right? How does this change? And I say, well, if I'm perpendicular, number one, I know I go through 2, 0, okay? But instead of my slope being 2, no, I have a perpendicular slope. So the perpendicular slope, that black line would be, as we know for perpendicular lines, okay, that it would be the opposite reciprocal. So instead of 2 over 1, the slope was 2 for the red line, I flip it over and I got to change the sign, right? The opposite reciprocal. So now we know we have goes through 2, 0, perpendicular to that red line, so slope is the opposite reciprocal. Now we say, oh, I have a point and a slope. Use the old point slope formula. Plug this stuff in. Okay, distribute that. Negative a half times negative 2, positive 2 over 2, which is 1. Okay, there's the black line there, that perpendicular line if you go back up, right? All right. Let's go on here. Write an equation given 2 points. Now, what if you're just given 2 points? You got negative 1, 3. You got 3, negative 2. What's the equation of that? Well, what two things do you need to write the equation of a line? You need a point, which we have a point. In fact, we have 2 points, right? And we need a slope as well. Okay, so we have a point, and then that negative 1, 3. We have a point. I need a slope. So let's find the slope. Y2 minus y1 over x2 minus x1. So negative 2 minus 3 over 3 minus the negative 1. We got negative 5 over 4. There's our slope. Okay. So find the slope first. Now we have a point. You can use either of these points, all right? And we use our slope. Okay, and then we use point slope formula again, just like we did before. So y minus 3, our m, negative 5 fourths, x minus the negative 1. Okay, then we go ahead and distribute that, y minus 3, 5 fourths, x, minus 5 fourths. Add the 3, get a common denominator. Of course, that's 3 over 1, so we want to get a common denominator of 4. So y equals negative 5 fourths x, and that's negative 5 fourths plus 12 fourths, or 7 fourths. So that's negative 5 fourths x plus 7 fourths there. Okay, that's how you find an equation given 2 points. All right, let's talk real quickly about writing and using direct variations. So first of all, a direct variation equation is you have two variables x and y, and they show it as long as you're in this form, y equals kx, where k is your non-zero constant, okay, which is referred to as a constant of variation. So let's think about this. It has to be in this form, right? So y varies directly with x based on k as a number, okay? Like let's say you have y equals 3x, k is 3, okay? And you're thinking about that and you're like, okay, it's just got to be in this form. Well, that sure looks a lot like this, right? Except what's your b? Well, your b would have to be 0. So a direct variation equation is simply a slope-intercept equation, except your y-intercept is 0, okay, which causes these two to vary directly, okay? So y will vary directly with x. So we know it goes through the origin, right? It will always go through the origin, a direct variation equation, okay? Anytime it's of this form, y equals kx or y equals mx. And then it's going to just, go up 3 over 1 in this case. So that's an example right there. Y equals 3x, right? That's an example of direct variation equation. Here's another one. How about y equals negative 2x? Again, what's your b? Well, 0, right? So if we don't even bother to write that. So we know it goes through the origin and it goes down to right 1. That's another direct variation equation. Yeah, here's another direct variation equation. Here's another one. Here's another one. Anyways, you notice these all go through your origin. Okay, so you have k. K is your constant of variation, but k is just a slope. Okay, so that's how they mathematicians have chosen to describe these as direct variation equation. Okay, so here's one. The variables x and y vary directly. Okay, as soon as you hear that, x and y vary directly, they vary directly, you are thinking to yourself, guess what? Y equals kx, because I know they vary directly, so it's going to be in this form. And then it says y equals 6 when x is 3/2. Okay, so number one, I'm going to solve for k here. Okay, I'm going to do part A. I'm going to write and graph this equation. Okay, so I need to solve for k. What's my slope? What's my constant of variation in this case? So 6 equals 2/3 k. Solve for k. You say, well, I got to multiply by the reciprocal here to do that. Okay, so 6k or 1k. Of course, we got 18 over 2 or 9. So k is 9. So now I know, since k is 9, I know what this equation is. It's y equals 9x. Okay, so I have going through the origin, up 9. Let me go by 3. And over 1. Okay, there's my part A. I'm graphing this equation. And now the part B says, okay, part B, find y when x is 3. Okay, so part B, find y when x is 3. Okay, find y when x is 3. I say, well, y equals 9x, that's my equation. If x is 3, what would y be? 27. That's it, right? When x is 3, it's clear up here, it's 27. Anyways, very good graph. Okay, see you guys soon.